Hello everybody, this is Mr. Longo here, and this is a video that's going to cover some properties of rational exponents. There are so many different styles of questions that fall under this category that there are going to be multiple videos that I've made for this. This is going to be kind of a blend of a bunch of different topics all wrapped up into one. So a lot of this stuff you've probably already seen. So if you would like, pause the video and try to answer as many questions as you think you can on your own. As soon as you're ready, click play and we'll go through some of them. So a little disclaimer about this video is there are many different ways to do these questions. And there is no right or wrong way to do it as long as you come up with the right answer. So make sure you know how to show it work. I will talk vaguely about different ways you can do these. And really after that, it's kind of up to you. Like number one, if you really wanted to, you can do a factor tree and draw out 15 A's and then just take the fifth root of it. And you would just circle 3 groups of 5. However, we could just say that 5 goes into 15 3 times because we're taking groups of 5. So 5 goes into 15 3 times. We could just say that this is a cubed. Okay, there's so many different ways you can do it. Really, it's up to you. In the next example, we have a little situation where we have a negative on the inside. So remember, if you're taking an even root, we run into issues with imaginary numbers when we take, even roots of negatives. However, if it's odd, you can go right ahead and move that negative to the outside because that's not really going to be much of a problem since we can take odd roots of negatives. So since we're taking the fifth root, again, there are multiple ways you can approach this problem. If you want, you can break down the 64 using a factor tree, and you would get 2 and 32, and then your 2 and 16, 2 and 8, 2 and 4, 2 and 2. Circle a group of 5, you're left with 2. So 1, 2 remaining. So you could do it that way, and then you would have 2 fifth roots of 2. The other way you can do this is to help yourself and rewrite the question. So we could call this a negative fifth root of 64 is 2 to the 6th power, and then we have our 8 to the 7th. And our next step would be as simple as how many times does 5 go into 6? Because we can pull out groups of 5. And it would be once, but we would have 1 left over. So we would have a negative 2. And inside of the radical, when we were done, we would still have a 2 remaining. How many times does 5 go into 7? Once with a remainder of 2. So we would be able to take out an A, and we would have to leave 2 A's on the inside. And now we are done. That is our final answer. So we would have negative 2a fifth root of 2a squared. Okay? So when we're working with these, there are so many different ways you can do these problems. If you might have done yours a different way, came up with the same answer, you are good to go. Now, some questions only look complicated. So when we take a look at number 3, you're like, oh my gosh, we have a fraction. But look at the exponents on each of them. 4 goes into 4 evenly once. 4 goes into 8 evenly twice. So our answer is just x over y squared. And we're done. So not all of these are designed to be difficult. It's really funny when you look at how some of these questions look so challenging, yet you're done with them in a matter of seconds. Now the next one has a few easy parts to it. Also has a few complicated parts to it. So the first thing we want to do is always look at our numbers. 18 divided by 6 is still going to give you 3. Don't subtract them and call it 12. That's only when you're working with exponents. 18 divided by 6 is still 3. Okay? So we've got 3. And sometimes I draw the fraction bar just to help keep my work organized. So we have r to the first power. Remember, when there's no exponent, there's an imaginary exponent of 1 over there. And we have 1/4 on the bottom. When we subtract, we would get r to the 3/4, because 1 minus 1/4 is 3/4. We have s to the 2/3 already on the top. And then we have this negative exponent, which means he's unhappy on the level he's on. He wants to go to the other side. So that means we have t cubed on the top. And we don't have anything else in our denominator. But now we can still simplify that some more. So we have to work with our rational exponents here. So our 3 and our t cubed, those guys are good to go. So we can just write 3t cubed right now. But now we have an issue where we have different denominators. So this is a 4th root, this is a cubed root. And we can only write our final answer with one radical. So what you're going to need to do with those is that's going to become r to the, change it to a common denominator with what we're going to have with s. And that would be 12. So that would be 9/12 and s to the 8/12. Now we have the same denominator, which means we have the same radical. So we can rewrite this final answer as 3t cubed and then the 12th root of r to the 9th and s to the 8th. And now we're finished with that example. Okay, so remember, you have to keep on simplifying till you can't simplify no more. But your final answer should be in radical form and only have one radical. That's why we needed to get that common denominator. Okay, number 5. This is the 4th root. So we really can't take the 4th root of 12. So that's not going to go anywhere. That's going to be left inside. But how many times does 4 go into 4? Once. So we can immediately take out a d. And there's no d's left over that we need to keep inside. So we're just going to have the 4th root of 12. And then we need to look at our e's. 4 goes into e to the 9th twice. So we can take out e squared, but we're going to have 1 left on the inside. And then finally, 4 goes into 14 a total of 3 times. So we can take out f cubed. However, that's going to leave us with 2 on the inside. Now once you're done with that, you're actually done with this problem. The 12 can't be simplified anymore. We are good to go. Now that we get to number 6, this one I'm going to tell you is a little complicated. And I'll remind you why when we talk about our denominators. But this one right here is g squared, and we're taking the 5th root of that, so that's nothing too difficult. However, we are dividing by the 5th root of 2h to the 7th. Now, you'll remember that we have a rule that we are not allowed to have radicals in the denominator. But we can simplify the denominator a little bit first, and that's because 5 goes into 7 once with a remainder of 2. That just makes it a little bit smaller to work with. So I'm going to rewrite that as the 5th root of g squared over, again, 5 goes into 7 once. We can take out an h, but we're going to have to leave that with 5 of 2 to the 1st power and h squared. Now, the reason I wrote the 1st power is because, remember, when you are trying to get rid of a radical in the denominator, you need to make it a perfect 5th power when we have a 5th root in the denominator. So we have 2 to the 1st power. How many more 2's do we need to give us 5? The answer is 4 more. We have h squared. How many more h's do we need to give us a power of 5? And the answer is 3. So we need to multiply both the top and bottom by the 5th root of 2 to the 4th power times h cubed. When we do that, this is what we're going to end up with. Now the denominator, the 5th root, this is all going to become 2h. But you have to remember we already have an h outside. So this would be an h times 2h. Remember, this step right here, the purpose of it was to get rid of the denominator, or the radical in the denominator. So 2 to the 1st and 2 to the 4th is 2 to the 5th. The 5th root of 2 to the 5th is just 2. h squared times h cubed is h to the fifth, and the fifth root of that is just h. Okay, but now, of course, we're just going to rewrite that as 2h squared for our final answer. But we need to multiply the top. We have the fifth root of g squared. We have the fifth root of 2 to the fourth power. 5 does not go into 4 evenly, so we're going to write that as 16. And 5 does not go into 3. So our numerator is just going to be the fifth root of 2 to the fourth power, which is 16, g squared, and h to the third. And again, we would just write our final answer a little bit nicer. So our final answer would be the fifth root of 16 g squared h cubed all over 2h squared. And that's it. Okay? So the last two, I will say, are extremely simple to do. They just look like they might be tricky in the beginning. But let's take a look at what we got here. Remember, when we are adding or subtracting, we're combining like terms. And both of these just have like terms of xy to the 1/3. So 2 minus 7 is just a negative 5 xy to the 1/3. But as mentioned earlier, we want to write these in radical form. So the final answer is just negative 5x cubed root of y. And now we're good. So that guy is finished. Finally, the last example. Remember, whenever you raise an exponent to another exponent, we just multiply. So this becomes x to the square root of 18. And the square root of 18 is just going to simplify to 3 root 2. So we are just at x raised to the 3 root 2. And we're done. There's nothing else you can do. That is a radical power. That is not a fraction where we have to rewrite that as a radical. That is totally acceptable. It's just a radical power. All right, that's it for this video on properties of rational exponents. This is Longo, and I'm out. See you, bye.